A very good morning, everyone, and warmly welcome. We are really happy that you have decided to dedicate 1 hour of your time with us this morning. My name is Tiina Tukia. I'm from Ruukki Construction, and it's my pleasure to be your host today. In this session, we will be introducing two groundbreaking facade solutions, Ruukki Emotion and Ruukki Forma. You will discover how perforation and backlit cladding can open up a world of design possibilities, and you will also learn about a versatile cladding solution that boosts energy efficiency by up to 30%. And at the end, we will share some inspiring references from across Europe that showcase the potential of these solutions. And let's see who we have here online today. I'm joined by three of my colleagues, Ruukki's own leading experts, who will guide you through today's session. First up is Johan Larsen, our production engineer, who will start with introduction of Ruukki Emotion. Then Kaupo Perttel, our technical support and sustainability manager, will share insights on Ruukki Forma. And last but not least, you will meet Carl Koppel, our design and engineering manager, who will showcase some stunning design possibilities and real-life cases from Europe. Carl will also join us a bit later as we keep only two presenters on stage at a time. But before we dive in, still a couple of practical notes. Feel free to ask questions throughout by typing them into the chat box on your right-hand side. And don't worry about taking notes. I will be sending you a recording of this session via email in the coming days. But now, without further delay, let's get started. Johan, over to you.
Thank you very much. I will scroll to next slide. And good morning from myself as well. My name is Johan Larsen. I work in Ruukki Construction since 2014 and here in Estonia in Pärnu cladding factory. My special fields are perforation and backlighting. My position is production engineer, but I also involved in some of product development and assisting designers in our 9 countries in design and also implementing orders to production. Here on background of my photo, you see on left side our very first attempt to create installation with Ruukki Emotion system. This is a photo maybe Finnish to recognize Tuomikirkko or Dom Church in Helsinki. And on right side there is so stylized perforation from photo of seabirds. And this was our first installation with ACM material with perforation. And now what we're gonna talk about is that we have 3 types of perforation, but the idea of this presentation is to introduce the possibilities of perforated cladding with backlight. We have 3 different ways to perforate material and 2 different ways to add backlight to this. And here is one project in Finland, in Lummetie, which is winter, how it's called? It's snow street in Vanda. To my eye, it looks very nice. And on top, you see original artwork created especially for this project from artists. This is introduction of what types of perforation we do use. The first, the full perforation, which means that we get already perforated material to our machines, and we can, in general, produce whatever product from it, but mostly it's used for design profiles. The material is perforated, so also all flanges and later what you have in joints, everything is perforated. Then we have a symmetrical perforation, and the idea is that you can choose whatever density pattern you want. No need to indicate, no need for any drawings. Just you need to indicate size of hole, distance between holes, and what should be free edges. And this type of perforation is produced on our production line during punching out cassette blank shape from raw material. And the last one, the most interesting one, for me at least, is art perforation, where we can take whatever image and to create, cladding from it. It can be like not very small. It can be 3-meter height, but it can be 30-meter height. The bigger the room is, the better is result. Starting from full perforation, it's, as said, it's used mostly for design profiles where we have 0.6 or 0.5 millimeter material, possible for all materials actually. We also do copper, stainless steel, zinc, etc. But the main idea, this material is already perforated when it arrives to our factory, and perforation is done from coil to coil. There is a table in middle indicating that we do ability to produce these patterns of perforation, but we also have list of sub-suppliers that can make other density perforation with different size, shape, or position of holes, arrangement, either it's square or triangle arranged. And it's often questioned that can you make very dense perforation? It's this question usually is related to projects when it's necessary to have airflow through wall, like parking houses. And we have tested it that if we perforate material with 40% perforation, then we make Ruukki design profile Rome S34 from it, which means that we actually shrink the raw sheet some 25%. And as a result, when produced this way, we have 50% of airflow through this cladding product. Now, so this is about symmetrical perforation. And the table below shows that, okay, we need 30% free area. And on second row, we have different diameters. And from this, it becomes clearly visible that how much number of holes we will have per square meter. Like with 50 millimeter, we have 152, and with 6 millimeter, we have more than 10,000. And considering that every hole has some cost, it explains a little bit when production of high density perforation is much more expensive than less density. Then also, like when it becomes very dense perforation, then the number of holes per square meter actually causes material to warp. It's not straight anymore. During punching, it may stuck in machine. We do have experience of it about 10 years, so we can give suggestions that, okay, do not do this, but instead we suggest you to the other solution. And on top you see two photos, and one is like single punch, and second one is what we call as cluster punch. If we calculate the number of holes per square meter, the right one actually allows us to put 9 holes per one punch, so reducing time for production 9 times, which is also like helps economize, so to say, production time and also cost of production. And also in some cases we do use sub-suppliers. Also related to this is that this I went too far. We can achieve a different visual effect just by using the same pattern with a little bit modified way. Here you see on top left is what we call square pattern. On top right it is rotated 45 degrees, and then we have a different visual effect. On bottom left there is pattern what we call shifted. Distance between rows and holes in rows are still the same, and therefore also cost is same, but visual effect is again different. And in bottom right you see triangle pattern, that the density is a little bit more, but in this case distance from each hole to each hole is exactly the same. It's shrunk a little bit from this original pattern. Now what effects those different patterns are causing is that if you rotate either pattern on panel or panel behind pattern, for example, we want to install cassettes diagonally on cladding. So you see that there is somewhat loss of information. I turn my mouse to show you something. You see that here we only lose one row of holes. We see it in design phase, but if architect cannot recognize it from very beginning, it may look interesting that okay, now we have a nice idea to rotate this pattern, but what happens is actually we're going to lose more and more information when we are rotating these. There are some ways to make the situation better, but one must understand that it has effect on a final result actually. My next slide, we can also generate random patterns. We have tools for it. So holes can be square or round or whatever shaped, triangular, and so on. Here's an example from Sweden. Also different shapes of holes on same cladding. And we can also do some completely different shape of holes. If a project is big enough, we can order specific tools in specific shapes. But before we actually start this project, we can create sample products with our ordinary set of tools. It takes more time, but you can see what it means. And the last system of perforation is art perforation, when we take actually some image, whether it's artwork, photo, or whatever, and we create AutoCAD file from it with predefined hole sizes and distances. So here is example that what has it. And we use two different modes to create this image. Dithering means that we have one size of holes, but either more holes or less holes. Half toning means that we have different diameters, and we have bigger holes in dark areas and less holes or no holes in light areas. To order art perforation is we first need to understand that what is our product. We create layout of elevation, then we put this image to it, and then you can send it to Pärnu, and we can proceed from this. You have numbered cassettes, which if installed right way, you will see the result. Every time you see this barcode or QR code in my slides, you can make a photo of it, and you have access to Google Street View to same locations where it's done. It's in Finland. So art perforation with square holes in Valmiera in Latvia. They have Olympic champion in this discipline, and it was a nice project. What else? There is one more effect how we can do art perforation. Square tool is turned 45 degrees, and the result is very airy. We can also do art perforation with cluster tool. Then the pattern is all the same, and edges are filled with single punches. This example photo is from Canada, produced in Pärnu. If you want better perforation density, we can add another pattern inside of the other pattern, getting more density. There is one example of Tallinn airport, when actually also airflow is important, but perforation density is not, because it's virtually open area, actually, because of design of those lamellas. So what we can do, we can either add some images to elevation, or we can make whole elevation as pattern. Company logos, artwork, you can see those closer when you get the presentation or record later. Illustration in Finland, very nice project. If it's not doable by perforation, then we do it by laser cutting at our sub-suppliers. It cannot be done with Ruukki products, except for Corten steel. Laser destroys color painting, but it's possible with powder paint. And I think, and this is last about this subject. We can also do perforation in aluminum composite, whether it's punched or milled by router. Different shapes are easy to do. So, and now I proceed to lighting systems. Here are two systems of Ruukki Emotion. Emotion 1 means that we have vertical aluminum studs, also carrying cassettes, and the light LED strip is built in the stud. We are always illuminating background, and you see illuminating background through perforated holes. We are not exposing lamps itself. And the Emotion 2 system, here in this case, we have one lamp below of this, and with light background, it reflects well enough to have a perfect image. So Ruukki Emotion first. When we designing cladding with backlight, we first need to recognize that do we want to, how we gonna see it during daytime or nighttime? Do we have white material and dark background, or vice versa, and so on. So, and do we want colors or not? Well, not, it means that it's white. To consider that we always need to have distance from the background, like up to, well, 130 millimeters is fine, and preferably light background, because light background reflects this light better. So, and this is in general design of this Emotion 1 stud. L profile will be connected to wall, and cladding cassettes will be installed on this wider part. There is one example of Emotion 1 installation in Sweden. So possible white with just turn on and off, so we can have dimmable. which means that we can change the brightness of light, or we can do RGB, which is fully controlled. You can turn from fade from black to green to red, and so on. And Ruukki delivers all necessary components for control, but not cables. It's up to a local electronics company. There's an example of Emotion One in Lohi shopping mall in Lohja, another in Finland. Okay, and now, like last part is Ruukki Emotion 2, which means that in this case we have lamps below the cladding, and lamps are powerful enough. I think in this case the elevation is some 8 to 9 meter high. Only one row of lamps is enough to illuminate the whole facade. The idea of development of this Emotion 2 system was to make it easy maintainable, because with Emotion 1, if we have some issues, we need to open the whole facade. In this case, we have actually continuous channel for lights, very easy to make cabling, very easy to clean lamps or to change if something becomes necessary. And it's a little bit less expensive than Emotion 1 system. There are few examples in this where you see this COOP logo on top. This is from project in Estonia where we have only lights on parapet area. The highest part of this cladding is 12 meter high, and still it's enough, only one 60-watt lamp on top to illuminate everything. This is we have in our cladding plant wall outside in Pärnu. Everybody is welcome to visit Pärnu cladding factory. We have a showroom with our products and materials. We have this Emotion 2 demo wall, and we are preparing in hopefully during like next few weeks also exposition of bigger cassettes and different products. And these are components of Emotion 2 idea, that it's a linear lamp. It has connection cable, it has fixing bracket, different options, and we are preparing to present also colorful version of it. Another important component of Emotion 2 system is the start we are using to make the cladding vertically transparent. So we want to have as less shades as possible. We redesigned our Ruukki's adjustable start to make it deeper, to have necessary room for lamps, and to make it less wide to decrease shades. And this is a standard product. You can adjust it from 100 to 160 millimeter depth. This is also some photos from our test wall. You can see different colors and different products and different patterns on wall. So symmetrical patterns. On top there are design profile with perforated some percentage. I don't remember exactly what. In middle, those horizontal rows are cladding lamellas. The one with eyes is also lamellas, and then cassettes Liberta 500 on left side, or Liberta 550 on right side. And, yeah, and just for fun, we also added colors to see that how different this may look. And I believe that it was like last slide from me. I will forward the control to my colleague Kaupo, and I will check about these questions you have sent during presentation, or if not so fast, then we can control it later by email. Thank you very much for watching. Kaupo, stage is yours.
Thank you, Johan. Yes, like Johan showed what is visible, how our emotion solution is visible and how it is made, those suggestions, then I go now under this facade cladding, and let's look how it is fixed to the main wall. And yeah, let's start. Yeah, shortly about me. I am education is construction engineer, and I am working as technical support and sustainability around the Balticum, and working in Ruukki already since last century. This is nice to say. Me. And yeah, and I take my today's topic is not all places where it's possible to fix our emotion cladding, because it's there can be different type of the walls. There can be some wooden frame behind of our facade cladding emotion, and there can be concrete wall. There can be whatever renovation need. And but I go a little bit narrow topic, and this is sandwich panel and how to fix our cladding elements to sandwich panel. And there is like, usually if you have some bigger sandwich panel building, then often there is some little part, for example, office part is covered with some external cladding. It can be emotion and backlighted, like we just looked, but it can be also different kind of claddings. And it's really that if you look the different buildings, some of them really looks like they are not made from the sandwich panels, and that it's really give life to the building look. That, for example, this building, that there basically nobody can expect that behind of those different materials are actually sandwich panels. And and why this is important, this sandwich panel, and different compared to the other materials is that fact that sandwich panel is a composite structure. It is basically made from the wool and very thin steel. And usually if we talk about the facade and facade claddings and whatever we fix to them, we are not planning usually to fix something to 0.5, 0.6 millimeter thin steel. That we prefer that there is or thicker material, 1 millimeter, 2 millimeters, then thicker than better if we think about the wind loads and weights of the facades. And but here, if we fix something to the sandwich panel, we actually doing that we are fixing heavy structure till the 50 kilograms to 0.5, 0.6 millimeter steel. And this is really, now, in one hand, if you don't think it through carefully, it can be dangerous, because screws really difference to keeping screw in 0.5 and keeping it in this tensile strength to pull out the screw for thicker steel. There can be differences 10 times and more, and it means that you have to use 10 times more screws also for fixing elements. That's why this is very important. And panels also are, range of the panels are very wide. There are used different thickness of the steels, different materials, different insulation types are used, and all those elements of the panel also influence the fixing system what we use with if we want to add some cladding there on top of the panel. And and we are usually using in our system That will be visible in the next slide. That panels are really different, and there is just one little comparison that if you compare the same thickness panel, this is the 200 millimeters wool panel, for example, then we can say that those are both our panels, but one of them are able to take wind load in the 6 meter span 1 kilonewton. It's like the average wind load in corner areas in the smaller buildings, but other panel with the same thickness is able to take 2 and 2.2 kilonewtons per square meter. It is very, very big difference. Panels looks the same. You both have 200 millimeters, both are wool panels, but really there are different. This bearing capacity is really different, and that's why it's important to follow that if there is plan to fix something to the panel, then always is at first needed to design the panel, and then think about this fixing of the cladding also, because they are connected. It's not good idea to look them separately, because sometimes this cladding material gives separate demands also to the substructure. And sandwich panel generally, as we know, is the biggest problem with sandwich panels is temperature load. That without any wind, snow, whatever other loads, panel bend outside till span divided by 100. It means in 6 meter span, panel can easily bend outside direction 6 centimeters. And that is really big deflection, and it's needed to take into account also if you design something on top of the sandwich panel. And that is just like the comparison that really, if you compare those two different wall panels, one is made from the sandwich panel, one is made from the thermopurlins or steel purlins. They are basically different materials. Panel external sheet, like I said, is very thin. Thermopurlins are usually 1.2 or even 2 millimeters in some cases. And it's nicely panel, like I said, will deflections because of the temperature loads are very big. Purlin wall is very, I would say, stable. There isn't, you can easily to calculate and set into place the maximum deflections. It's not the bending of the color of the purlin. And really, if you want to increase the strength of the sandwich panel, if you fix there something, you basically increase the panel thickness. You can increase the sheet thickness on the panel, profiling type and insulation strength. But if you want to increase the strength of the thermopurlin wall, you basically play with the thicknesses of the purlins and distances between of them. But they are different things to really, they both are metal-based external walls, but they are acting and design is really different. And that is the reason why we made this guidance and summary of the design instructions and call them Ruukki Forma, that it's really take all those little details into account, and if we want and plan to, if architect or designer is planning to add something to the sandwich panel, then this is very good guidance, and all those main things which is needed to take into account are nicely here also visible. And like I said, there is the many important steps. One is really to design the panel, not only to the wind loads and whatever other loads, but also about the cladding weight and deflections according to the cladding need is needed to take into account. And there are like two separate calculations. If we calculate the panel grooves, then we have to add also this weight of the cladding what will be added there, and if we calculate the fixing of the cladding themselves, purlins, then there is also separate rules, and as you see, we set how to say, this is the limited amount of the loads what we allowed to use if we fix some purlin to our panel external sheet. The maximum tensile and shear resistances are 0.3 kilonewtons per one fastener. And this is also important to take into account. If those forces are in the same places, then you basically can use summary capacity 100%. And it means that if tensile is used 50%, then you can't use shear resistance also more than 50%. And that is also very important to take into account. And let's go further. The basic solution, how it works, is that we are making purlins system on top of the sandwich panel. We basically fix those purlins, are they vertical or horizontal, relatively often to our thin external sandwich panel steel, and to this purlin we are fixing our cladding materials, and that's really great stronger support for the external cladding. And you basically can use, if you fix the cladding themselves, you can use the normal fixing elements what is standard for the cladding materials, not needed to think it other way. And there is also visible that for example our Liberta cassettes, if you use the longer cassettes than 3 meters, for example, then you have to limit the movings of the sandwich panel also with very strict way. That's even span divided to 400. That is like just example that it's not allowed to use these 6 centimeters deflections. Shortly, Juhan showed also this our adjustable stud that is good to use if there is needed to move the external cladding more away from the sandwich panel or substructure. There is possibility to do it till 175 millimeters, and then will be those lights playing a better way in sometimes in there under our cladding. And the crucial thing is really to, if we fix something to our sandwich panel, then this screw type is very important. Or is it screw, is it rivet, is it whatever type of the element? But about the screws, we all used to talk about the maximum drillability of the screws. That this is the screws drill 2 millimeters and even 10 and 15 millimeters. But in the thin steels is most important minimum drillability, and it means that it should be written in the screw documents that this screw is allowed to use in, for example, like there is visible 0.4 millimeter thickness steel, and basically if you take this loading data of the screw, which is inside to this auto document usually, then you see that if there isn't 0.5, 0.6 thicknesses, then you basically can't use those screws in that place. And that's you have to make separate tests on the site, and it's a totally different topic then, because you have to choose according to the minimum reliability, not the maximum. And as you see there, that is also a big difference, that you can't rely only to the screw supplier data, because as you see, screw supplier allowing to use 0.6, 0.97 kilonewtons per one screw, but we limited it with 0.3. And this is because of the panel, not because of the steel, because the connection between the steel sheet and insulation, this will be broken before the screw will be out from the steel. And that is also very important not to go over of that. And that limitation should give every panel supplier to their panel also, because they are really different. I saw in we have 0.3 kilonewtons, some supplier have 0.2, and which means needed are 30% more screws than we are declaring, and etc. Okay, and yeah, that was like shortly about this our Ruukki Forma. This is, like I said, it's not just bunch of the materials. This is a full solution, carefully think through and designed and supplied together. That is Ruukki Forma. Thank you. And I give the word now to the Karl. Karl is then showing those end results and references, how this forma with not visible substructure are really look like. Thank you.
Thank you, Kaupo. Okay, let's move on to my part, starting with small introduction. So yeah, my name is Karl Koppel. I'm the Baltic Design Engineering Manager, situated in Estonia, actually sitting in our cladding factory. I've been in Ruukki for 6 years, and then started my career here as a cladding product engineer. And so I have done quite a lot of different cladding and cladding solutions, and also few standard products. For example, our Primo Skyline series is the one that I have helped to develop. And then from education point of view, I have a master's degree from product development and production engineering. Good, but yeah, moving on. Let's take a look at some of our examples that we have done. First up, we have a Ruukki Forma example from Lithuania. This is now one of the latest projects that we have finished. It's not our official reference in our web pages yet, but just as a sneak peek, I can show it to you. So basically, there we delivered Ruukki sandwich panels, around 2,000 square meters. With micro profiling in 2 tones, so RAL 7016, also known as anthracite gray, and 9006 or silver. And in the office part, we also delivered our original 102 cassettes, around 250 square meters. This, as you can see also on the picture, around the windows, so with corner and U panels. Some additional shots of it. So on the left side, you see this sandwich panels in those 2 tones mentioned. And then on the right side and above, the pictures of this Liberta Original 102. So also looks very good. This 102 is now with visible fixing, so there's a 20 millimeter joint between the panels with a screw inside, but from afar you cannot really see it. Next up, we have our Ruukki Emotion example, one from Latvia, this Baltikovo office. This is also a reference on our web pages, and I've added here a QR code. So if you're interested, you can find additional information about this project from our web pages through this QR code. To this Latvia or Baltikovo office, we delivered also Liberta Original 102, around 280 square meters in this special yellow color, and also had this art perforation and backlighting. And this is now with Emotion 2.0, where we have one light bar at the bottom of this one column, bringing light to all the panels at once. So some close-ups as well, and also a night and day comparison. And all of our perforated claddings are powder painted, just to protect the steel edges from edge corrosion. Moving on, another Ruukki Forma example from Estonia, Rimi supermarket, where we also delivered 2 sets of products, starting with sandwich panels in this RAL 9020 tone, around over 1,000 square meters. And on top of that, a bespoke solution of triangular lamellas, which were double-sided powder painted, and it was actually aluminium, and over 9 kilometers actually of this these lamellas. On the next slide, I can show you also a close-up. So really nice effect that it's a V-shaped lamella with one side painted red, another side painted blue, and can give this really nice chameleon feel or look to it, that as you drive by, the color changes. But yeah, rather simple product to put on our sandwich panels. Next up, we have another Ruukki Emotion example, this time from Finland. This you could also see in the introduction video. It's actually a big server or data center somewhere in Finland called Lumi. It's also a reference on our webpage, and there we delivered a Ruukki Primo, which is our aluminum composite or ACM product line, a bespoke solution. So over 1,000 square meters of ACM in RAL 9010, which is white, and in addition, perforation and backlighting was also used in that case. So yeah, as you might see some from these close-ups, so this art perforation and special shapes and backlighting, and this data center also doubles as a seminar room, as you can tell from the chairs here. And then we have another Ruukki Emotion example, which is also our cover sheet for this webinar, this time from Sweden, a swimming hall in Täby, where we provided Ruukki Liberto Elegant 550, which are our hidden fix vertical cassettes. And also with art perforation and backlighting, once again over 1,000 square meters in this RAL 9002, and also some RAL 1711, so some gray panels as well. And some close-ups of it are right here. So also a good comparison how it looks like during the day and in the evening when the sun starts to go down. So really nice effect. And once again, this random pattern art perforation was used here. And also some windows were covered up with this cladding, giving a really nice effect inside the building and also acting as a sunshade. And we have more of such references. Here a small introduction, or actually instruction, how to find those in our web pages. So if you go to our web pages, then you can select go to walls and roofs. So this is our building envelopes side. From there, you can see the button references marked with number 2 here. And from there, you can find this perforation and lighting, perforation and backlighting references. So finding those, and then you can see all the projects we have done with perforation and backlighting. There's also possible to see sandwich panel references or Ruukki Forma references, also can be found there. And for ease of access, I also added a QR code here, which takes you directly to this perforation and backlighting references. Good. Okay, but that's it from my side as well. Thank you.
All right, very good. Thank you very much for your presentation. We have now some time for questions, and I see that Johan from the background has been actually answering the questions a lot related to Ruukki Emotion. There is one question that I believe that maybe Kaupo, if you cannot, does Trayban integration to Revit make a calculation of Ruukki Emotion's load-bearing capacity structure?
Basically this like external cladding to sandwich panel is at the moment currently available in our Trayban program, and you can in this Trayban program you can do it, but not currently yet in this Revit add-in, what we are using then new, but it has direct connect to the Trayban program, and if you basically add all this needed data to the Revit, and then it's just these additional things you can do directly in the Trayban program. Yeah, but it is in development phase, as I understand that it's hopefully soon is coming also this extra load and taking this cladding also into account. Yeah.
Okay, let's see if we have any other questions coming.
Yeah, there was question about this screw inside the sandwich panel, that if we use it in different places, is there different tension, bigger tension load you can add to screw, but this is really, how to say, we use our 0.3, and it's really, if there is places you can test it and really think it through, and then it's actually is stronger in the joint area of the sandwich panel, where we have different steels, many layers of steels even. But if you go further to in the middle side of the sandwich panel, then it's definitely not allowed, not recommended to go more than 0.3. But it's hard to use in real life. That's why I am saying that if you design those fixings and try to use only the joint area, it's probably not wise to do. Yeah, that's easier is to use more screws in the flat area of the sandwich panel, not probably. Yeah, because in our areas, those wind loads what we have, you just move the support stud, decrease the span between the support studs, and you immediately have less load to the one screw. That's the way to go. Yeah. Okay.
Good. Okay, let's still wait for if there are more questions, but in the meanwhile, I would like to thank you very much for participating on my behalf as well, and thank you for Johan, Kaupo, and Carl for the excellent presentations, and as said at the beginning, you will receive the recording of this webinar in a couple of days, and we hope that you found this interesting and beneficial for you. But as there are no any questions, I would like to wish you a good rest of the week, and we are going to end the webinar. Have a good day.